sequencer and hear any of the other slave devices while you are recording. However, this setup only allows you to record. It doesn't let you play back and hear the music that you've already recorded. So, turn the page and let's move on to System 3B. This will be a playback configuration. To hear music from the sequencer, it needs to be the master. In this situation, we're using the sequencer as the master. Therefore, we don't even need to hook up the controller. That's why it's grayed out. Pause the tape now and fill in the diagram where the sequencer is the master and the drum machine, A and B, are the slaves. Does your setup look like this? Sequencer out to drum machine in, drum machine through to A in, A through to B in. Great, you're doing fine. By now you can probably see how useful it is to sketch things out on paper before actually tackling the MIDI spaghetti. The repatching you just did with System 3A and B would have to be done every time you wanted to switch between recording and playback. However, there is another way to go. If your sequencer provides a feature called echo, or sometimes echo back, you can eliminate a lot of cable maneuvers. Echo is a function that adds a temporary MIDI through to your sequencer's MIDI out. Turn back to System 3A for a minute. If this sequencer provided echo function, instead of using MIDI through, we could connect the sequencer's MIDI out to the drum machine's MIDI in. From there on, it's still MIDI through to MIDI in, through to in. In this way, you can play the controller and record your performance into the sequencer. Since we're using the sequencer's MIDI out, we can also hear what's already been recorded. In addition, the echo feature allows you to hear the part that you are currently recording. This means everything stays connected just the way it is during recording as well as playback. However, some sequencers do not provide an echo function. So, the next step is to add a splitter so we can leave both the controller and the sequencer hooked up. Now turn to System 3C and try connecting the keyboard and the sequencer into the splitter as controllers. The drum machine, A and B, as well as the sequencer will all be slaves. Before filling in the diagram, here's another important point to keep in mind. Be aware of accidentally creating a MIDI loop. This occurs when a device's MIDI out is routed back to its own MIDI in. This causes everything in the loop to lock up and stop working. Should this accidentally happen, simply power all the units down. Then trace the MIDI signal flow, make the appropriate changes, and turn the power back on. This situation is more likely to occur when using devices that split or merge MIDI messages. In this system, watch the sequencer. An important factor is the flexibility of our splitter. The splitter in this system allows you to store several different configurations in its memory. We'll want one setup for recording and another for playback. The sequencer will be a master in one system and a slave in the other. Remember, everything will stay hooked up to the splitter and it will handle the routing for you. With this in mind, pause the tape now and take a moment to fill in System 3C in your workbook, making the appropriate MIDI and audio connections. As your MIDI system grows in capabilities, the options for connecting and using each component also increases. Therefore, this diagram presents just one way to hook up System 3C. In this case, connect the controller's MIDI out to MIDI in number 1 of the through box, and the sequencer's MIDI out to MIDI in number 2. These will be our two master controllers. Next, connect through number 1 to the drum machine's MIDI in, through number 2 to A's MIDI in, through number 3 to B's MIDI in, and through number 4 to the sequencer's MIDI in. The splitter will store several different routing setups, and we can recall them at the touch of a button. Therefore, you can program it to recreate System 3A for recording and System 3B for playback. This way, we eliminate a potential MIDI loop. If you already own a splitter, On some units, the through jacks may be incorrectly labeled MIDI out, even though they function as MIDI throughs. Just something to look for. Now, back to our system. What else do we need to do to get things working properly? First, set the drum machine sync to MIDI clock. This allows rhythm parts in the drum machine to play back in time with music data from the sequencer. The drum machine will also receive start and stop commands from the sequencer. In other words, pressing start on the sequencer will also start the drum machine, which will play back in time with the music. Pressing stop controls the sequencer as well as the drum machine. Well, congratulations. Once you've made it this far, you're well on your way to untangling MIDI. You can now begin designing and setting up your own MIDI system. As you do, keep in mind the 8 important system setup guidelines listed in the workbook. These will help make things go more smoothly.